Assalamu alaikum students. The topic of today's video is heat capacity at constant pressure. So in this video I am going to explain the heat capacity at constant pressure. So first of all, you know the formula for heat capacity. C is equal to change in heat divided by change in temperature. Because heat capacity is actually the amount of heat that is required to raise the temperature of a substance by 1 degree C or 1 Kelvin. Okay, so heat capacity is actually the amount of heat that is required to raise the temperature of a substance by 1 degree C or 1 Kelvin, and that will give me a formula. C is equal to change in heat divided by change in temperature. This here is the inexact differential because, as you know, Q is a path function whereas T is a state function. Since T is a state function, so its differential is exact differential, that is D, whereas Q is the path function and its differential is sigma, and that is the inexact differential. So now, you know the first law of thermodynamics. According to the first law of thermodynamics, first law of thermodynamics will give me change in heat is equal to delta E plus P delta V. Okay, that is according to the first law of thermodynamics. Now I just have to plug in this value here. So plugging in this value will give me an answer dE plus P dV divided by dt. Okay, so now I have to just separate this dt to this one and to this one, and because I am going to give this denominator to both of these, now I have to change this differential into partial differential, because now my energy will be dependent on temperature at constant pressure. And again, when we are showing the dependency, then we have to use the partial differential. Okay, so now differentiating this equation with respect to temperature at constant pressure, we get Cp is equal to d. Now in place of this d, I am going to write just like this. And this here is showing the partial differential. Okay. Okay, so now as you can see here that the Cp means the heat capacity at constant pressure, and now you know the equation for enthalpy that we have determined from the first law of thermodynamics is given by H is equal to E plus PV. Okay, so this is the equation for enthalpy that we have calculated from the first law of thermodynamics. So we have to now differentiate this equation with respect to temperature at constant pressure. Okay, now we have to differentiate this equation with respect to temperature at constant pressure, and that means since we are differentiating with respect to temperature, so I again have to use this sign here, because again we are using the partial differential that is dependent on another quantity. So that's why we are using this differential, and again I am taking at constant pressure, and this E will again be just like this, plus again P is constant, so that will go out, and again I am left with V divided by T at constant pressure. Okay, so now as you can see here that this part of equation and this part of equation are same, so I can just plug in the value for this part of equation here. Okay, as you know that this part is equal to this part, and again this part and this part is same, so I can just say that if this part and this part is same, then this part and this part should also be same. So I can just write it as Cp is equal to change in enthalpy divided by change in temperature at constant pressure. So that was the heat capacity at constant pressure. Hence the heat capacity at constant pressure is defined as the rate of change of enthalpy with temperature at constant pressure. Okay, so that was all for today's video. Inshallah, see you in the next video. If you have any questions, you can ask in the comments.